For today's lesson, kicking off chapter 12 on matrices, the plural of the word matrix. And today, just looking at basic matrix operations. So, what is a matrix? A matrix is a way to organize a set of data. It's like an old-fashioned spreadsheet, Excel, Google Sheets, okay? The numbers or variables in the matrix are called elements. It's usually enclosed in brackets and named with uppercase letter. The size of the matrix is described by the number of rows by the number of columns. Always remember, rows is first. If you go to a concert or a show, athletic event, people talk about what row they sat in first. Right? They don't care what column where they sat in the row. It's always, oh, I sat in the first row or I sat in the last row. So remember that to help you, that rows, then columns. Then each element is referred to by its position in the matrix using subscripts. So if you had a 3x4 matrix, the element in the third row, second column would be at A32, right? It's matrix A, row 3, column 2 would get written that way. So in our example matrix here, we have matrix A. They ask, what are the dimensions here? We see the brackets setting it off, right? These brackets. And so to find the dimensions, then we count the number of rows. There's 2 rows, and then there would be 4 columns. So it is a 2x4 matrix. For the identifying the value of A12 or A12, A tells us to look in matrix A. The 1 tells us we are looking in row 1 and 2 in column 2. So this would be the -1 right here. Identifying the value of A23. The 2 tells us row 2, right here. The 3 tells us we're looking here in column 3. So that value would be -3, right? Always rows and then columns. So an old-fashioned spreadsheet here. Caitlin is looking at some universities. She's got her data organized in a matrix. So it asks us to organize the data in a matrix, right? We would basically bring all of these labels and put them outside of the matrix, right? We'd put our tuition, room and board, and enrollment on the outside of the matrix. And then we would copy in all of the values, right? The 7250, the enrollment, right? And then we would just go through and we would bring this data in without any sort of label. I'm not going to take the time to do that now. I think by now you should be able to copy data in, right? The 6160, 5352, right? The 12609, etc. And so what would be the dimensions of the matrix? Well, it has 3 rows and 3 columns. So it's a 3x3 matrix. The value of A32 will be in row 3, right? Down 3 rows. So we're in this row here, row 3, column 2. It would be this value, right? The 6,280. So when we are adding and subtracting matrices, the first thing we have to check is, do they have the same dimensions? If they don't have the same dimensions, you can't add them. If they do have the same dimensions, you add or subtract the corresponding elements. So you match up the terms, you add or subtract them. Right, so a quick check, this is a 2x2 matrix, right? 2 rows, 2 columns. A 2x2 matrix, 2 rows, 2 columns. And then I am just going to add these 2 matrices together, right? So I'm going to start by going 6 plus a -3 would give me 3. 4 plus 1 would be 5, right? And then I'm going to go to the second row, -1 plus 0, and then 0 plus 3, right? So there is my quick addition of those two matrices. Same size, just match up the elements and add or subtract. Example 4, however, we have a 2 by 3 matrix and a 2 by 2, so I cannot add them. So you could write not possible, dimension error, no solution. Any of those would be valid answers because they don't have the same dimensions. Next up, we have multiplying by a scalar. We are going to scale our matrices, matrices, plural, matrix, singular. Right, so we are going to scale our matrix by this k factor. So if I have matrix A here, they want us to find 2A, so 2 is my scalar. I am going to multiply every term, every element by the 2. All right, so 2 times 2 is 4. 1 times 2 is 2. Negative 1 times 2. 2 times 3. 0 times 2. 5 times 2. Right, there is my new matrix. So that is multiplying by a scalar. We take the matrix, multiply every term inside by the same value. Lastly, we have a multi-step problem. For example 6, they want us to find 4a minus 3b. So the first thing I would do is check dimensions. Am I going to be able to subtract these when I get to that point? They're both 2 by 2s, so I'm going to be good there. Right, first off, I need to find 4a and then 3b so that I can subtract them. Right, so we're going to start by doing some scaling. Right, our scalar is 4, so I'm going to multiply all of my elements in matrix A by 4. So 2 times 4, 3 times 4, negative 1 times 4, and 0 times 4. And then when I get done with matrix B, I'm going to need to subtract. For matrix B, everything gets scaled by 3. So negative 2 times 3, 1 times 3, 0 times 3, and negative 1 times 3. When I go to subtract these then, just making sure that I'm looking out for any double negatives, right, subtracting a negative. So 8 minus a negative 6 would give me a positive 14 right, because of this double negative. 12 minus 3 would be 9. Done with the first row. Negative 4 minus 0. And 0 minus a negative 3 would give me 3. So that is it for our introductory lesson to basic matrix operations.